Welcome to The Explainer. Today, we're embarking on a totally mind-bending mathematical journey. We are going to explore a recent paper by independent theoretical physicist and mathematician Dr. Ahmad Rihan. His work formally introduces something he calls the Planetary mathematics model. It's basically a framework that attempts to take some of the absolute most bewildering paradoxes in mathematics and physics and translate them into one unified geometric language. So if you've ever been curious about the profound mysteries of infinity, the weirdness of quantum mechanics, or just the hidden architecture of the universe itself, you are in the exact right place.
To get us started, picture this. What happens when you add 1 plus 2 plus 3 plus 4 and you just keep going, just adding every single positive whole number all the way to infinity? Intuitively, it seems like a no-brainer, right? The numbers just keep getting bigger, you're constantly adding positive amounts, so the answer must just be some massively incomprehensible, endlessly growing infinity. I mean, that is just common sense. But mathematics, especially when we push it to its absolute limits, rarely actually conforms to our everyday common sense. The answer, remarkably, is -1/12. Yeah, -1/12. Just let that sink in for a second. You add up an infinite sequence of positive, growing integers, and somehow, some way, you arrive at a tiny negative fraction. It feels like a complete mathematical glitch, like an absolute contradiction. Okay, let's dive into this because understanding why this happens is exactly what today's paper attempts to solve. Now, don't worry, we have a very clear, logical map to guide us through these seemingly impossible concepts today. We'll hit 4 main parts. 1. Taming mathematical infinity. 2. The planetary mathematics model. 3. Subatomic and cosmic symmetry. And finally, 4. A geometric language.
All right, let's jump right into part 1, taming mathematical infinity. So the secret sauce here lies in Ramanujan's summation and zeta regularization. I know, those sound super intimidating, but conceptually, they are really just specialized mathematical tools. When a series diverges, meaning it just rockets off to infinity in a straight line forever, these methods actually allow mathematicians to assign a precise, finite value to it. By using something called the Riemann zeta function and evaluating it at -1, they can rigorously extract that finite value. And when they do that exact process for the sum of all natural numbers, the Riemann zeta function evaluates to exactly -1/12.
Now, you might be thinking, come on, this is just some abstract math trick, right? Well, there are heuristic derivations, think of them as logical shortcuts, where manipulating these series cleanly solves to -1/12. And sure, while this is completely justified by strict mathematical proofs, its physical validity is what's truly mind-blowing here. In quantum physics, there's something called the Casimir effect, which measures a very real attractive force between 2 uncharged metallic plates in a vacuum. To correctly calculate that actual, real-world physical force, physicists literally have to plug in -1/12 as the sum of all natural numbers. It's built into the physics. Okay, so if adding them up does something that's strange, let me ask you this next provocative question. What happens if you multiply them? 1 times 2 times 3 times 4, infinitely. This regularized infinite product is another mathematically divergent monster. Any guesses on what it equals? The answer is the square root of 2 pi. No way, right? Now, what's really interesting here is the sudden, totally surprising appearance of pi. Think about it. Pi is the ratio of a circle's circumference to its diameter. But we are just multiplying straight, linear numbers in a row. So where on earth is a circle coming from? Why is pi suddenly showing up in a straight line of integers?
Which brings us to section 2, the planetary mathematics model.
To visualize this crazy abstract math, Dr. Rihan contrasts 2 totally different arenas. In flat spaces, counting numbers on an infinite grid means the series diverges linearly, in a straight line forever. It just goes to infinity. But he proposes that reality actually operates on curved spherical geometries, kind of like a planet. On a sphere, if you travel in a straight line forever, you don't go off into infinity. You eventually wrap around and fall back on yourself. In the planetary mathematics model, that bizarre -1/12 simply encodes negative curvature on a spherical manifold. That linear divergence folds into a finite regularized geodesic value. Basically, the infinity gets tamed by the actual curvature of the space it lives in. Dr. Rihan lays out 3 foundational axioms that build this planetary mathematics model. First is the curvature regularization principle. This just states that these regularized infinities correspond exactly to intrinsic geometric invariance, like the curvature or volume of a surface.
Second is four-fold symmetry, which mirrors the four-directional moves you can make on a planetary surface. Think north, south, east, and west. And third is the pi agent hypothesis. This is exactly where the paper addresses why pi suddenly appeared when we multiplied out to infinity. The paper states, pi unifies 2D, circular, and 3D spherical formations, extending multiplicatively to regularized products. In this model, pi is proposed as an active architect. It's almost like a force that takes flat, linear infinities and curls them up, generating circles, spheres, and even higher dimensional manifolds. According to the paper, this is exactly why pi emerges out of nowhere in an infinite product. It's quite literally the geometry of the universe asserting itself.
Moving right along to Section 3, subatomic and cosmic symmetry. To understand the quantum side of this, we just need a quick anchor term, quaternions. Simply put, quaternions are a four-dimensional number system over real numbers, and we use them to calculate and double-cover three-dimensional rotations. They are absolutely essential for describing how particles spin in quantum mechanics.
See, in the subatomic world, particles like electrons have something called a Dirac spinner, and they behave incredibly strangely. Think of a normal object like your coffee cup. If you rotate it 360 degrees, which is 2 pi, it goes back to exactly how it started. But if you rotate an electron 360 degrees, its mathematical state actually twists into a negative version of itself. You literally have to rotate it another 360 degrees, a full 4 pi rotation or 720 degrees total, to fully restore its identity. This is famously known as Dirac's bell trick, and it demonstrates a really complex four-fold symmetry right at the absolute baseline of quantum reality. So the crucial point is how this model seamlessly aligns two wildly different scales. Subatomic spin is guided by this four-fold rotation of Dirac quaternions. Meanwhile, macroscopic geodesics are guided by planetary four-fold symmetry, the actual dimensions of spherical planetary surfaces. Dr. Rehan's framework essentially argues that the math governing a tiny electron spinning in a void is geometrically identical to the math governing paths across a massive curved planet.
And this all ties back together beautifully. Remember our infinite product of 1 times 2 times 3 equaling the square root of 2 pi? The model shows that this exact regularized infinite product generates the normal Gaussian distribution. You know, the classic bell curve when you map it onto the geometry of a sphere. A straight, infinitely divergent product folds perfectly into a natural curve that literally defines probability in our physical world. And that brings us to our final section, a geometric language. Let's move to and see how this builds into the future of theoretical physics. Dr. Rehan's paper opens up some incredible interdisciplinary tests. By using these planetary lattice models, physicists could potentially predict quantum energy spectra. There are open conjectures about calculating higher mathematical dimensions, and amazingly, because this model bridges the microscopic and the macroscopic, there is a serious call for empirical testing of these mathematical constants directly in the orbital mechanics of actual planets and stars. As Dr. Rehan beautifully puts it in the paper, this framework transforms divergent analysis into a geometric language of the universe, with pi as architect and fourfold symmetry as structural principle. It really gives the math a majestic, almost architectural feel. The paper suggests we aren't just doing sums on a chalkboard, we are literally reading the blueprints of creation. Which leaves us with this final, fascinating thought to ponder today. If these wild, divergent infinities, things we honestly used to think were just math breaking down completely, are actually just the geometric language of the universe revealing its curvature and symmetry, what else is math trying to tell us? What other strange behaviors hiding in our equations are actually profound truths about reality, just waiting to be translated? Thank you so much for joining me to explore this incredible paper today and keep questioning the infinities around you.